Today we're going to explore writing your first generic class, and we're going to do it by implementing a stack, which is a very particular data structure in programming where you're able to add at the top of our data structure and then remove from the top. What we're doing though is we're going to use an array list as the underlying data structure to store the data. This is no different from an array list using an array behind the scenes to implement the behavior of a list. So let's take a look at some of the methods that we should be implementing. To add and remove to our data structure, we're going to be implementing push and pop. So as I mentioned earlier, a stack is going to be LIFO, which is last in, first out. So when you place something at the top of our stack of plates here, when you remove from it, you're also going to remove the last thing you added. So that's why it's last in, first out. Another way to discuss it would just be you add at the top of the stack and you remove from the top of the stack. Unlike an array list, we cannot remove anything anywhere else at a specific index. We can't remove from the bottom of our stack, for example. And so anyone wanting to use our class here is going to be limited to push pop in terms of altering the elements within the list. New in this project or this lab is going to be the fact that we are adding a parameter up here to create a generic class. Essentially, you are wanting to not hard code what type of data you can store within this data structure. So by adding this notation, you can then use that as your type where you would have originally added the data type for your getters, setters, constructors, any other helper methods that you may have had. So capital T is usually used when you're thinking about types, when you're writing generic classes. So now the first thing we're going to do is we're going to create our data structure that we're going to use as the underlying storage. As I said earlier, this is going to be an array list. Let's do that. Array list T data. So as you can see here, when we've been working with array list, we kind of use this angle bracket notation, and we would personally use whatever object types we wanted here, right? Could be strings, could be the objectified primitive types like integer, capital D double, capital B boolean. Could have been any of our custom classes that we created. But we have seen something similar before. But now it's going to be using T, which is whatever was used to declare and instantiate this class, or an instance of this class, I'm sorry. After that, we're going to add our constructor, public stack. Our constructors are going to be pretty similar as well, especially our default constructor. And then remember that the constructor is in charge of initializing our instance variables. Instance variables. So it makes sense here that we are creating that data structure that we'll be using. And that's pretty much it to get going. All right, so now let's work on adding. So adding to a stack is known as pushing, and what we're going to do is we're always going to push to the top. So push to the top of the array list. Now, in terms of an array list, we have not really thought of it in terms of a top and the bottom of this array list. So we can think of it as the beginning and the end of the array list. So pushing will add to the end, and then popping will remove from the end. So if that's the case, then all we have to do is use our array list to add at a specific index. That will be the end of the list. And then followed by whatever we're adding. So this will add to the end of our list. Now to remove, which is popping, it also has to be from the top of the stack. In this case, for an array list, it's going to be from the end. So we're going to do a remove from data.size -1. From there, everything else is pretty self-explanatory. The size is going to be how many elements you pushed, and including how many, or less minus all the elements that you popped. In other words, it's just the size of a list. From there, empty, we already know that an array list has an empty, or does it? Or you could check the size, right? There's many different ways that you could figure out if your list is empty. So one way is to see if it's size 0. Peeking, on the other hand, will allow you to look at the top of the list of our stack without removing it from the list. And that's just going to be, instead of a remove up here, we're going to do a data.get, which is that. Now, what I'm not doing here, though, is I'm not really protecting against invalid uses of these methods. So if I do a peek here and our data structure is empty, well, it's going to try to access this. So wherever it's appropriate, you may want to check. So if our data is empty, let's just return nothing. And then anything else you can double check. So for example, it's probably not good to try to pop from an empty list. And so if it's empty, we can just return nothing. And that's about it, I believe. So that should cover all our bases. Now, of course, what you want to double check is just to fix all of your commenting. So at the very top, we're gonna try to use Java doc style, perhaps, or just multi-line comments. So describe what this method is supposed to do. Although I'm not really sure why. Oh, it's being weird. Anywho, describe what this is doing. Fix the formatting here. I'm going to leave that up to you. I was just writing short code, but that's pretty much it. So this is how you can implement this idea of a stack using a data structure that we're familiar with, which is an array list. So if you've forgotten a lot of the basic methods, your getters and setters for an array list, make sure to cover some of the problems in the array list section